Hi all, welcome to the 7th part of the chapter motion. In this video we shall discuss few numerical examples. So let's begin. A stone is thrown vertically upwards with an initial velocity of 40 meters per second. Find the maximum height reached by the stone. What is the net displacement and total distance covered by the stone? So in this question, we are talking about a stone that is being thrown vertically upwards. The initial velocity of the stone is given as 40 meters per second, and they are asking us to find the maximum height that the stone has reached after throwing. What is the maximum height the stone reached, and what is the net displacement of the stone, and what is the total distance covered by the stone. These are the things that is asked in the question. So let's write down all the given data. So here first of all they have given the initial velocity. So let's write u is equal to 40 meters per second. And here they are throwing the stone vertically upwards. That means let's imagine a stone here, and this stone is being thrown up. So this they have given the initial velocity with which the stone is being thrown. So initially the velocity of the stone is 40 meters per second, and then what happens after it reaches a height, a particular height? It will fall back, right? Now one more point that you must keep in mind is, when a stone or when anything is being thrown up or is being fallen down, the acceleration that acts on this body is the acceleration due to gravity, that is g. Acceleration due to gravity. This is something that we already know, right? What is acceleration due to gravity? Acceleration due to gravity is the gravity of the earth, or it is the acceleration, or it is the force with which the earth pulls any object towards itself. That is gravity, right? So any object that is being thrown into the air gets acted upon by this acceleration due to gravity. The actual value of acceleration due to gravity is 9.8 meters per second square, but for convenience we can take 10 meter per second square as g. That is, for easy calculation we can take g as 10 meters per second square. In case if in the question they have given g is equal to 9.8 meters per second square, then you must take this value, this value 9.8 meters per second square. Alright, so we are talking about the stone that is being vertically thrown upwards. So we have the initial velocity of the stone, and we know that the acceleration that is being acted upon the stone is g, that is acceleration due to gravity, and we are taking its value as 10 meters per second square. Again, now I am going to tell you an assumption that is always taken in these kinds of questions. That is, when a stone or when anything is thrown up, we assume that it is being thrown with an initial velocity, right? And after reaching up, we assume that the object stays there for a very minute second, I can say, and then it falls down. So after throwing the object, it reaches the particular height, and then it stops there for a second or so, and then it falls down. So we take, when the object is being thrown up, we take the final velocity to be 0 meters per second. This is an assumption that is always taken in these kinds of questions. That is, when anything is thrown into the air, after reaching the particular height, it stops there for a second or less than a second, right? So it stops there and then falls back. So thus we take the final velocity of the object to be 0 meters per second. So these are the data that is given in the question, and then they have asked us to find the maximum height reached by the stone. The maximum height means this height, h. Alright. Then what is the net displacement and total distance covered by the stone? Alright, so let's first calculate what is h. For this, I have initial velocity, final velocity and acceleration. Can you think of the equation of motion that we can use in this scenario? Can't we use this equation? V square minus u square is equal to 2as. We have final velocity given, we have initial velocity, we have the acceleration, and we need the distance covered, right? That is the height reached by the stone, that is the distance covered by the stone. So instead of this a, I'll replace this a as g. So my final equation will be v square minus u square is equal to 2g h, and I'll write h instead of s because we are calculating height, right? Now here we need height, right? So let me write h is equal to v square minus u square by 2g. V square is 0, 0 square minus 40 square by 2 into 10. Again, I am reminding all of you, in case if in the question they have given use 9.8 meters per second square as the value of g, then you must take that value. Here nothing is given, so for our convenience we are taking value of g as 10. Now here if you calculate, we will get the answer as 80 meters. That is 80 meters is the maximum height reached by the stone. Again, next they have asked us to find the net displacement of the stone. So what is the net displacement? We know for finding displacement we are bothered about only 2 points, that is the final and initial points. If we know the final and initial points, we can find displacement easily, right? So here when the stone is being thrown up, then what happens? It will come back to the same position, right? That means here the final and initial position of the stone will be the same. That is, when we are throwing the stone upwards, it will come back or it will return back to its original position. Thus, we can take net displacement to be 0. But the total distance covered by the stone is not 0, it is total distance covered by the stone will be, the stone is first thrown up, that means it is traveling a distance of 80 meters, right? This height we got it as 80 meters. So first it is going up, that is it is covering 80 meters, and then from this position it is coming back to the origin, that is its original position. So that is again 80 meters. So plus 80 meters. It is going 80 meters up and then it is coming back 80 meters down. So here the total distance will be 80 plus 80, that is 160 meters. An aeroplane starts from rest with an acceleration of 3 meters per second square and takes a run for 35 seconds before taking off. What is the minimum length of the runway and with what velocity the plane took off. So here there is an aeroplane that is starting from rest. So from the first line we get that the initial velocity of the aeroplane is 0 because the aeroplane is starting from rest. And then this aeroplane takes a run for 35 seconds before taking off. That is, before the aeroplane is actually flying, it is running on the runway for 35 seconds. So for example, if this red line represents the runway of the airport, then the aeroplane is moving for 35 seconds and then it is flying. So they have given the time t is equal to 35 seconds. So they are, and in the question they are asking what is the minimum length of the runway. So for the aeroplane to move for 35 seconds, what is the minimum length of the runway? Or we can say what is the minimum distance covered by the aeroplane, right? So that will be same as the minimum length of the runway. What is the distance covered by the aeroplane? If we find that, that will be the minimum length of the runway. Minimum, the runway should have that much length. Only then the aeroplane can move, right, on that runway. So they are asking S, the distance the aeroplane has moved. And then next they are asking the velocity of the plane, the velocity with which the plane took off. That means that is V, the final velocity. The velocity at this point, right? This point is when the aeroplane is taking off. So at this point, what is the velocity? That is the final velocity. So we have the initial velocity 0 and the time the aeroplane has moved on the runway, that is 35 seconds. We need to calculate the distance covered by the aeroplane and the final velocity of the plane when it took off. So first we can find S. In order to find S, we can use this formula. S is equal to ut plus half at square. Here, since u is 0, this complete term will turn out to be 0. That is 0 into 35 plus half into 3 into time is 35. I actually forgot to write the acceleration of the aeroplane here. It's a is equal to 3 meters per second square. It is given here. Now if we calculate here, it is 3675 by 2, which is 1837.5 meters. So the distance moved by the aeroplane on the runway is 1837.5 meters. So this runway should contain minimum this much. Minimum length of the runway will be 1837.5 meters. Therefore, okay. Next, let's calculate the final velocity of the plane. That is v, right? We can calculate v easily from this equation. V is equal to u plus at. This is the first equation of motion. So here u is 0, a is known, that is 3, and t is 35. The answer comes out to be 105 meters per second. This is the final velocity of the plane. A train is traveling at a speed of 90 kilometers per hour. Brakes are applied so as to produce a uniform acceleration of negative 0.5 meters per second square. Find how far the train will go before it is brought to rest. So here they are asking us to find out the distance travelled by the train after the application of brake. Alright, so it is given that the train is initially travelling at a speed of 90 kilometers per hour, and then brakes are applied and the train is brought to rest. So from this we can get that the initial velocity is 90 kilometers per hour, that is this one, and then the final velocity will be 0 because finally the train is brought to rest. So from this line we get that v is equal to 0, and then they have given that the train is having a uniform acceleration. After the brakes are being applied, it is having a uniform acceleration of negative 0.5. Why negative? Because it is negative acceleration. Since the brakes are being applied, the acceleration will be negative. So acceleration A is equal to negative 0.5 meters per second square. So the negative sign indicates the direction of acceleration. And then they are asking us to find the distance travelled by the train after the application of brakes. That is, before the train actually stops, how much distance the train will travel. So we will have to find S here. So now we can use this formula 2as is equal to v square minus u square to find out the distance travelled by the train before the application of, after the application of brakes. Okay, so we will be using this formula. Now before substituting the values onto this formula, we must make sure that all the units are consistent. Here, as you can see, the initial velocity is given in kilometers per hour, whereas acceleration is given in meters per second square. So let's convert kilometers per hour to meters per second, since meter per second is the SI unit. So as you all know, we have done this before also, how to convert kilometers per hour to meters per second. That is, let me write down here, u is equal to 90 kilometer per hour, right? So this will be 90 into 1000 by 3600 meters per second. So in order to convert kilometers per hour, you need to multiply that quantity or value with 1000 by 3600. Now if you solve this, you will get the answer as 25 meters per second. So our initial velocity turns out to be 25 meters per second. Now we can use this value in our calculation to find S. So let's find S. S is equal to v square minus u square by 2a, right? V square is 0, 0 square minus u square is 25. 25 square by 2 into negative 0.5. Please note that the negative sign only indicates the direction. Now if we solve this, the answer we will get is 625 meters. Since we are finding the distance, we get the answer in meters. So this is the final answer. That means the train will travel 625 meters more after the brakes are applied. The speed time graph for a car is shown. Find how far does the car travel in the first 4 seconds. Shade the area on the graph that represents the distance travelled by the car during the period. Which part of the graph represents uniform motion of the car? So, in this question we have been given a graph, that is speed time graph. Now, the first part of the question is asking about the distance travelled by the car. So, they are asking the distance travelled by the car in the first 4 seconds, and they are also asking us to shade the area on the graph that represents the distance travelled by the car during that 4 periods. So, we all know how to find distance from a speed time graph, that is the area under the graph of a speed time graph or a velocity time graph will give the distance covered, right. So, in the question they are asking us to find the distance travelled by the car in the first 4 seconds, that means in this time period. So, in this time how much the car has travelled, that is the question. So, for that, as said, it is the area under the graph. So, let us draw a perpendicular like this. Okay. Let us draw a perpendicular like this touching the graph. So, now this area, let me shade, this area will give the distance covered by the car, right. Now, in order to find the area under the graph, what I am going to do is I am going to split this shape into a square here. Though it seems to be a square, it is a rectangle, and 2 triangles, and then I will add up all the areas and then find the area of this shape. So, this is what I am going to do. So, here this is the rectangle that I am talking about. So, here this side is 2 seconds, right, and this is 4 meters per second, and this is the first triangle, this is the second triangle. Now, distance is equal to, first I will take the area of the first triangle. This is my first triangle, second triangle, and this is the third shape, that is the rectangle. So, first it is half into base is 2 seconds, right. So, that is into 2, then height is 4, this length is 4. I am taking the value 4 from the graph, plus, so this is the first triangle. Now, the second triangle, for the second triangle, half into base is 2, between 2 and 4, right. So, it is 2 into height is again 2, it is between 4 and 6, 6 minus 4 is 2, alright, plus, next this square part is, this length is 2 and height is 4, this is the height, so that is 4. Now, if I calculate this, that is 4 plus 2 plus 8, my answer will be 14 meters. So, the distance covered by the car during the first 4 seconds is 14 meters. In the next part of the question, they are asking us to mark the uniform motion of the car in the graph, that is which part of the graph is representing uniform motion. So as we all know, what is uniform motion? In uniform motion or during uniform motion, the car will have same speed or constant speed. So here when you look at the graph, which part of the graph is having the same speed or constant speed? It is this part, right? Here the speed in this region, the speed is not changing, it is uniform, that is 6 meters per second. So we can mark the graph, let it be MN. So the part MN of the graph represents uniform motion. This part MN on the graph represents uniform motion.